If you've been finding it difficult to understand kinematics, then you just clicked on the right video. This guide will help you to understand what kinematics is, importance of kinematics equation, and how to solve problems on kinematics. But in this video, we are going to focus on kinematics in one dimension, the x-axis to be precise. So make sure you have your note and pen as you would like to write some formulas and solve some questions. Let's get started. What is kinematics? Kinematics is the study of motion without reference to the forces which cause the motion. Kinematics is used to calculate the velocity, acceleration, and position of an object. Before we dive further, there are some things you need to note. Quantities in physics can either be classified as scalars or vectors. Scalar quantities are those quantities having only magnitude but no direction. A good example is distance. And vector quantities are those quantities that have both magnitude and direction. An example of vector quantity is displacement. Displacement is the distance traveled in a specified direction. Let's say a man travels 6 km north. North is telling us the direction which the man travels. In the case of distance, it has no direction. If a man moves 10 meters east and moves back 6 meters west, the total distance covered is 10 plus 6, which is equal to 16 meters. But the case is different for displacement. It moves 6 meters in the negative direction. So the displacement is 10 minus 6, which is 4 meters. Distance and displacement can be the same if an object moves only in one direction. Distance is always positive, but displacement can be positive or negative depending on the direction. These are basically the differences between distance and displacement. Another example of scalars is speed. Speed is a scalar quantity. It has magnitude but no direction. Velocity, on the other hand, is a vector quantity. It is the displacement per unit time in a specified direction. The formula for velocity is displacement over time, and for speed, it's distance over time. Let's say these two cars are moving at the same speed of 50 meters per second. Their velocity is different because one is moving 50 meters per second east, while the other is moving 50 meters per second west. To calculate the average velocity of an object, the formula is displacement over change in time. You need to note that speed is always positive, but velocity can be positive or negative. Acceleration is also a vector quantity. It is the change in velocity over time. Change in velocity is the final velocity minus the initial velocity. So when an object is moving with constant acceleration, it means the velocity of the object is increasing by equal amount in equal time intervals. Let's say a car is moving with a constant acceleration of 2 meters per second square. This means that after 1 second, the velocity is going to be 2 meters per second. 2 seconds later, the velocity will be 4 meters per second. And 3 seconds later, the velocity will be 6 meters per second. You will notice that the velocity is increasing by equal amounts in equal time interval. A body can also move with constant velocity. A body is moving with constant velocity when it covers equal distance in equal time interval. And a body with constant velocity has zero acceleration. Always keep that in mind. Now let's move to equations you need to know to solve problems on objects moving in a straight line. Yeah, you don't need to cram anything. When an object is moving with uniform speed, distance is equal to speed multiplied by time. If you are using d as displacement, it will be velocity multiplied by time. Also, the instantaneous velocity is the same as the average velocity. Instantaneous velocity is the velocity of a body at an instant. When a body is moving with constant or uniform acceleration, constant and uniform are the same. The equations you need to know are d equals average velocity times time. But here, instantaneous velocity is not equal to average velocity. And average velocity is equal to v final plus v initial divided by 2. If we break down this formula, d will be equal to v initial plus v final divided by 2 times t. That's the first equation. From the definition of acceleration, we know that acceleration is equal to change in velocity over time. If we make v final the subject of the formula, then v final equals v initial plus at. Another equation is d equals v initial t plus 1 over 2 at square, half at square. And finally, we have v final square equals v initial square plus 2 ad. Now, whenever you see the letter d, you can replace it with x final minus x initial and rearrange the equation if it is necessary. Now let's check out some examples. On a cool afternoon, the driver in a truck moving at a velocity of 50 km per hour suddenly observed a stuck girl on the road 20 meters ahead. He hits hard on his brakes to obtain a uniform retardation of 5 meters per second square. How far will he go before stopping? Will his truck hit the girl before the truck stops, or will he be able to stop before hitting the girl? Let's find out. So from the question, we have retardation, which is also known as negative acceleration, and also the initial velocity of the truck, which is 50 km per hour. The truck is going to stop, which means the final velocity is 0, and we have to calculate the distance traveled. Which formula can be used to solve this question? It's v final square equals v initial square plus 2 ad. We need to convert 50 km per hour to meter per second. To do that, we multiply 50 by 1000 divided by 3600. So 50 km per hour to meter per second is 13.9 0.89 meter per second. Now we can input the values, and the answer is 19.29 meter, which means the truck did not hit the girl. It stopped close to her. Let's check out another example. An airplane, initially at rest, undergoes a constant acceleration of 3.5 meter per second square down the runway for 20 seconds before it takes off. How far does it travel down the runway before taking off? In this question, we have to calculate the distance traveled by the airplane before taking off. From the question, we know that the acceleration of the plane is 3.5 meter per second square. We also know the time. The plane is starting from rest, so the initial velocity is 0. The formula we can use to find distance in this case is d equals v initial t plus half at square, because it contains everything we need. So d equals 0 plus half times 3.5 multiplied by 20 square, and d equals 700 meter. When you multiply this together, this is the distance the plane traveled before taking off. Try this one. A train with an initial velocity of 40 meter per second is subjected to a uniform deceleration of 2 meter per second square. The time required to bring the train to complete halt is... You can pause this video and try solving it, then play it back to check if you are correct. The initial velocity of the train is 40 meter per second, and the final velocity is 0. The train was moving at a uniform deceleration of 2 meter per second square. To calculate the time required to bring the train to stop, we use v final equals v initial plus at, and we have 0 equals 40 plus minus 2t, and 0 equals 40 minus 2t. 2t equals to 40. Dividing both sides by 2, we have t is equal to 20x, 20 seconds. This is the time required. What is the total distance covered by a train before coming to rest if its initial speed is 30 meter per second with a constant deceleration of 0.2 meter per second square? In this question, a equals negative 0.2, and it has negative sign because it is deceleration. V final equals 0. V initial equals 30 meter per second. So to find the distance, we need an equation that contains these values and also contains d. This is the suitable equation to solve this problem. So we have 0 equals 30 squared plus 2 times 0.2 times d, and 0 equals 900 minus 0.4d. 0.4d equals 900. Dividing both sides by 0.4, and we have d equal 2250 meters. And the last question for this video, A boy runs back from a grocery store at a constant speed of 3 meters per second. He reached home 30 seconds later. How far is the grocery store from his home? First, you need to note the word constant speed. The formula to find the distance when we have constant speed is d equals vt, v times t. So the distance is equal to 3 times 30, which is 90 meters. That's all for this video. I hope this video helped you. Thanks for watching and have a great day.